Welcome everyone, I am Juan Chavez and I'm going to present the participation of Neuralmind at COLIEE 2021 on the legal case entailment task. So our submission was the best scoring submission among all participants by a significant margin. So today we are going to explain why this happened and what we think are our major contributions to the field of legal NLP. So the name of our paper is To Tune or Not to Tune, Zero-Shot Models for Legal Case Entailment. I'll start by explaining the title so that we can start to get into the subject of this presentation. Zero-shot models are models that have not been adapted to your target task. In our case, it's legal case entailment. So in this paper, we are going to be using models that have not been trained or fine-tuned on the COLIEE dataset. We only perform inference of these models on the COLIEE dataset, and they are never exposed to the data either during training or fine-tuning. So the legal case entailment task, for those of you who may not be aware of, it's a task that consists of a decision, and this decision must be matched with a reduced number of cases that entail the decision. So we are talking about maybe 1, 2, or at most 3 cases that justify the decision. So this is an entailment task, a task in information retrieval. And to perform this task, we use zero-shot models while comparing these zero-shot models also with models that have been fine-tuned on the task. Before we move on, I'd like to give an outline of the structure of this presentation. I'll try to follow the general structure of the paper. I'm going to give an introduction of the subject matter of zero-shot models and how they perform in distinct contexts, and also the related work on not only zero-shot models but also on legal NLP, and finally the methods, results, and the conclusions we can take out of our research. So our introduction starts by asking the following question: can zero-shot models transfer well to the legal domain? Now, even asking this question is a huge step because it's a large step compared to previous research, because previous research did not even ask this question, because we often make implicit and unexamined assumptions about training and fine-tuning. So there's a tendency to investigate architecture rather than questioning basic assumptions about how you should train and fine-tune a model. So there is a tendency to believe that fine-tuned models are superior to zero-shot approaches when we come to very domain-specific problems such as legal case entailment. However, what we found is that even though there is no strong evidence in the legal domain that zero-shot models can have good performance, we get evidence from neighboring fields. So on the past edition of COLIEE, the state-of-the-art was achieved by the interpolated scores of BM25 and a fine-tuned BERT model. And in some editions of COLIEE, we found that transformers could not score much better than classic approaches such as BM25 or TF-IDF. So this led us to believe that maybe we should investigate alternative approaches rather than simply fine-tune the models on an unbalanced data set, because the COLIEE data set is very unbalanced towards negative examples, because you have a decision and a set of cases, and only a very reduced number of cases are entailed with your decision. So the data set is unbalanced, it's very domain specific, so general purpose transformer models will have a hard time being adapted to the task. So we got evidence from neighboring fields that a zero-shot model would have good performance. This comes from past research from one of our authors, Rodrigo Nogueira. He proposed a solution with zero-shot T5 on medical data sets, and his model achieved the best scores, either the top score or the second best score on all shared tasks he participated with this model. So this led us to believe that maybe we could just bring this to the legal domain. Now we are going to look into the related work. Previous research in the legal domain focused on pre-training domain-specific models, multitask learning, and fine-tuning. We could not find, as far as I can tell, there are no studies on zero-shot models on the legal domain, and more precisely speaking on the COLIEE tasks. However, Yin et al. Achieved successful results by applying few-shot and zero-shot models to Q&A and multi-label classification tasks. So we have some evidence from customer review datasets and social media sentiment analysis. This sort of data has already been submitted to zero-shot models with a certain degree of success. We also have the famous paper that released GPT-3, language models are few-shot learners. So in this paper they released, or better saying, they publicized a gigantic language model that is capable of achieving good performance on several tasks, either on the zero-shot approach or a few-shot approach where it is exposed to a very diminished amount of examples. So there's this trend in NLP to focus on approaches that are either zero-shot or few-shot, that save you computer resources that are quite expensive to spend in production. So you don't have to fine-tune models over and over to each and every domain and task you deal with. You can use zero-shot or few-shot models that have been trained on massive data sets on your task. So this is a key step in bringing transformer models to production environments and making them more accessible and so on. So given this trend, we now are going to talk about our method and our investigation. So we investigated the following models. So there's BM25, which is a baseline classical machine learning algorithm. There's also Mono T5 zero-shot. Now, this model was fine-tuned for one epoch on MS Marco. There is this data about zero-shot models that you should be careful not to overfit the model on the general purpose dataset, otherwise it won't transfer well to your task. And then for the sake of comparison, we also fine-tune Mono T5 on the COLIEE legal case entailment dataset, and we also fine-tune the BERTA model. Now the BERTA is here not for any special reason, but because at the time we started our research, it was the best ranking model on the GLUE benchmark for entailment. So we thought that it would perform well on legal case entailment after being fine-tuned on the COLIEE dataset. We tried many here for the deburder model. We did many experiments on the best learning rate, the best warm-up steps, the best parameters, and we also experimented with data augmentation. So you have the decision that must be matched with a certain small amount of cases. However, this decision is taken from a base case, and so far nobody has tried to take advantage of the base case. As far as I can tell, all participants of COLIEE until now have just ignored the base case where the decision is extracted from. And in our research, what we did was to take the paragraph of the decision, move a sliding window over the decision's paragraph, and then each chunk is considered to be a new decision. So you can expand your data in this way. You can expand your data for fine-tuning, and then you have a data set which is less unbalanced. And we also did some experimentation to find the right amount of positive and negative data, the right amount of sampling that would allow us to achieve good results with this model. So compared to zero shot, that's a lot of effort. So other things that I should mention is that we used an answer selection method, because all these models here, either Mono T5 or the deburder, all they give you is a list of entailment scores. And you know that at most 3 cases are positive and the rest are negative for entailment. So you must have a set of rules to decide whether you're going to pick 1, 2, or 3 cases, and if you are going to pick, then which cases we are going to pick. So we did an extensive grid search of heuristic rules for this task, and other than that, another experiment we also did was a very simple ensemble of Mono T5 and deburder. And we simply merged the lists of selected paragraphs, removed duplicates by keeping the highest score, and then you apply the heuristic rules as usual. So it should be emphasized that this ensemble is not made through an architectural improvement. We are not changing the architecture of the models. This is simply merging the list of predictions and treating them as a single list. So that said, now we can take a look at the results of our experiments. So what we see here is that we use the 2020 dataset of the COLIEE legal case entailment task as our development set, and the proposed test set of the workshop this year was our test set as well. So what you see here on this right column are the final results of the workshop, and what you see here on the left side are the results of our development set during our experiments. So we were not aware of the results here on the right until after the workshop was over. So after the submission period was over. So first thing we noticed is that the deburder had a very good performance on our development set, but then it dropped significantly on the test set itself. Now there are many reasons for that. We are not sure why this happened. Maybe it could have been avoided by cross-validation. We did not have time to do cross-validation of all these models. But anyway, what happened is that our fine-tuned models had a worse performance than the zero-shot model, Model T5 zero-shot. So you can see here that without any training, our Model T5 zero-shot model was able to surpass all these transformer models that we spent many hours trying to find the best parameters, the best data augmentation technique, and the best way to perform training, how many epochs, what's the best learning rate. So all these considerations took us many hours of continuous experimentation. However, on the other hand, you can get this score with Model T5 zero-shot instantly. And in fact, we could only surpass Model T5 zero-shot by using an example of the Berta and Model T5. And so you can imagine that with the fraction of the computer resources we had to deploy to get this result of the ensemble, Model T5 zero-shot was able to achieve the same results. So this brings us to some of our conclusions. Well, I believe our strongest conclusion is that zero-shot approaches should not be ignored as strong baselines for legal case entailment tasks, and I think for legal NLP in general. I mean, when you see results like this, you start thinking if fine-tuned models is even worth it, because you can get these results and you can very quickly implement them in a production environment and actually make products with such solutions. Another point is that adaptations of the fine-tuning procedure for small domain-specific datasets should be investigated in the future. So maybe we are just fine-tuning the models in the wrong way. There's some research on modifying the ADAM optimizer. There's some research on adversarial fine-tuning, and all this research is about how to adapt transformer models to small domain-specific datasets. And we did not have time to go deep into this line of research, but it definitely should be investigated in the future and compared again with zero-shot approaches. And we believe that some of our findings are also applicable to other tasks, such as legal question answering. So a question answering task can be modeled as an entailment task, and you can use zero-shot models that have been trained for entailment on DMS Markov dataset or any other dataset for question answering. So you could easily transfer our findings to legal question answering, and in fact you could transfer them to any legal task.